Hey everybody, welcome back. So today we're going to be doing some more programming. I made some tweaks to the launch code that was failing yesterday, so we're going to see if we can get that to work. Our goal is to at least get into Kerbin orbit in a fully automated fashion, and then ideally I'd like to start working towards getting some ScanSats out to lunar orbit, so we can start getting a sense of the biomes there, and so we can get a sense of where our first Kerbal mission should be to. So yeah, let's get started. All right, it's a very foggy morning. That's kind of cool. All right. So first of all, I want to use the same probe from last night, which is the ScanSat 1. Now, we're going to use this, but we've made some major changes to the code. So let's go ahead and just kind of look at what we got here. We got the swivel engine because that gives a lot more stability on the ascent. We've obviously got the command core here, and we're going to make a couple little changes to the way the action groups work. Namely, so 1 opens the service bay, 2 starts the scan, 9 is our custom command that initiates the script. What we're going to do is we're going to set 8 or maybe 0 to reboot the KOS module. So I'm hoping that with this, if we need to, we can turn off the command to take over manual flight. I'm just going to say toggle power. Let's call it like that. All right. Now, let's look at the code a little bit. Give me a second while I fetch from Git. Yes. Okay, so I made some new changes to the way that this orbit system works. So first of all, I kind of prettied everything up a little bit. So we have these functions such as ascend now actually have a sort of dynamic readout. So we can start at the solid ascent first. So rather than just printing events as they sort of happen, we get a lot of information now, and it's printed actually at a specific coordinate on the screen. So we've got the header up here, 1, 2. We've got the params here, which is the parameters that we've defined for the specific vessel. Here, we've got the stage number, stage delta V, maximum thrust, altitude, apoapsis, and ETA to apoapsis displayed on the screen, updating every 1 second until max thrust is 0. In other words, until the solid stages are expended. And then we clear the screen, and then we ditch the solid stages, and we finish that. So that then goes to the next one, which is the ascent stage. And we do kind of the same thing in the ascent stage, except that I updated the code here as well. So the ascent stage now basically gradually aims towards the horizon as we ascend. So that's this little bit of math right here. And obviously, so I haven't actually tested any of this, by the way. This is just some stuff I cooked together on my break today. So we'll kind of see how well it works. No promises. But essentially what this is saying is it checks the base, which is either set to a specific altitude, or it's the ship's altitude already. So if we were flying a liquid stage rocket, we might want to say start the turn at 5,000 meters. However, if we're flying a solid stage rocket, we're going to be a lot higher than that by the time those solid stages are expended. Like I think like 20 or 30,000 meters. And so in that case, we'll have let's say 25,000 meters to 80,000 is the range that we're making that curve over. So we calculate the difference between those two here. We have the base is it's whichever is highest, either the start altitude in the parameter or the ship altitude. The difference is okay, so I'm already seeing a thing here. So we say target altitude minus base. We then have a local ascent angle, which is 90. And then we do our header here. We lock steering to bearing and ascent angle, so straight up, but at the bearing provided by the script, parent script. We lock throttle to 1. So we just say max throttle, basically. We stage if empty. That was the method we made yesterday that just dumps the stage if there's no more thrust. We print the display again, and then we do this. So what this is basically saying is we take the difference between the altitude and the base. So let's say if we started this process at 10,000 meters, if we are at 12,000 meters now, that means we're 2,000 meters higher. We divide that by the difference, so the total distance we're trying to cover, which gives us a percentage, times 90, which is an angle. And then we have this aggression. So aggression is 1 by default. If you leave aggression at 1, then you will ascend straight up at the bottom of the arc and then straight horizontal at the top of it. But if I say aggression is 2, then by the time I'm halfway up that altitude, I'm then headed perfectly horizontal. I might end up tweaking this a little bit. We'll see what we want to do. But I can also make it a more vertical ascent by saying an aggression less than 1. And then I just make sure that if I have a high aggression, which means that this could be a total of more than 90, that this is never less than 0. So I'm not trying to sort of flip over the other direction. Or point down, for instance. Alright, so that's the ascent stage. The orbit stage also has some modifications to it because yesterday when we were testing, one of the reasons it was locking it was actually not because of Kerbal alarm clock, it was because we had some runaway loops. So we're skipping those loops now, and now what we're doing is we are trying to reach ship status equals orbit rather than just trying to raise the periapsis. Because what was happening is that a lot of times we'd overshoot the apoapsis, so we'd start dropping down, and then we were trying to raise the periapsis to the original height of the apoapsis as measured. But of course, by the time you're past the apoapsis, if you raise the periapsis enough, you become the periapsis, and so you never actually get that high. Okay, so basically we're just saying until the ship status is orbit, and either there is no atmosphere, or if there is, the periapsis is above the atmosphere. We go through, same deal here, every 10 times a second, we update all of these stats, and we stage if empty, and if we are less than 20 seconds from the apoapsis, or if we've started to fall, we just burn at full throttle, and if we are dropping, we also angle slightly upwards to counter that a little bit. Otherwise, we set the throttle to 0. So that way, if we push the apoapsis too far, or if we are not at the apoapsis yet, the throttle stays at 0. So hopefully, this should complete the orbit. And then finally, we have circularize up, which I didn't really touch too much, so it still has the old style prints. So we'll kind of see how that goes. Finally, made a couple changes to core. I have the log event and log error now. So this is in that new style if we are sort of using the terminal as a little HUD panel. If we say log event, it'll just print an event at the bottom of the thing with a domain. So you can say autopilot or kind of whatever string you want there. And a log error, which is the exact same thing, except slightly above it with a slightly different styling. That just stays there until you write it over something else until you clear the screen. Finally, we're saying set terminal height to 24, which ideally should set the total height of the terminal to that height so that we can use it for everything else. And this is called from core.ks at the start, so this will be true for all vessels and probes going forward. So, like I said, I've not tested this out at all yet. Let's make sure we have the params correctly first. We also don't need these prints anymore because we're using that new header method. So, ascend solids. Let's check out what that looks like. So ascend solid still just has bearing. That's fine. Ascend solid 0. Solid ascent towards a polar orbit. And then we have ascend to apoapsis over 72,000 meters. 72 km, let's just say. Let's double check the parameters on that. So this one you can see actually needs a little more work. So ascend, start altitudes. We have bearing, target, and start. So here we have put bearing and target, and we'll just say start is, let's say 10,000. Doesn't really matter because we're flying solids. And I'm fine with a 1.0 aggression, so I'm going to leave that out. Complete orbit. Here's the complete orbit. Still just has the one parameter, bearing. That's fine. And then we finally have circularize. So we're just going to hope that this works, basically. Yeah, let's try it out. So we are once again going to fly this thing. We're going to see if there's any errors when we first launch it. Okay, there's some kind of error for sure. Can't find file lib/orbits.ks. That's a new one. Did I mess that up somehow? I might have. Download and run. First of all, we actually kind of want that to be true, that force variable. Download and run. Force exists. Which one? Run path, file path. I have no idea why this isn't working. Well, let's find out. So I don't actually know how to navigate this file system. Let's look at the docs. Okay, CD, like that. So I've got core.ks in there, but not lib.ks apparently. I need to be quotes. Let's try that. There we go. Okay. So I'm clearly missing something that I had working yesterday. So we have copied lib/orbis.ks to local storage and executing. So what happens if we do this? Copy path. I'm wondering if it's too big. Let's try that. Switch to 0. CD lib list. It is too big. So look at that. The size of orbis.ks is just too large to load onto this device. So let's Revert to vehicle assembly. We're going to have to put some more memory on board the Kerbal core. We're already sort of running into the limitations of this system. That's fine. So we're going to give it 40,000 disk space. And we're going to launch it again. Would it be nice to have a little bit of an error to show that we're just not able to copy that? But I guess we'll deal with that. All right, that worked that time. ScanSat ready, AG9 to begin. That's good. Okay, to the command center. As always, we're going to put our cameras in place. We're going to turn on the orbit map. So we actually have quite a cool map coming through here from our previous satellites. That's actually looking very nice. Really getting the map of Kerbal going. I don't know if that changes up here on the screen once we take off. I'm not really sure how this works. Let's find out, I guess. Okay, we'll put the attitude on here. We're going to put the Kerbal on here. So, moment of truth. I'm going to quick save now that I got this set up. Although I'm still not sure this really works that well when it loads in, but we'll deal with that later. Okay. So far, so good. You can see there my beautiful GUI display. It seems to be working all right. The delta V is going down. Altitude is going up. Apoapsis is going up. So once this gets down to 0, the next stage should begin. Got that beautiful view up there. That's looking great. Shit. Okay. So far, so good. I don't know why this is happening. So our ascent is clearly not working. It is very funny to be doing this in atmosphere and very crazy. Yeah, that's not going to work. All right. Revert the flight to launch. We're going to modify the scripts a little bit. One thing I think I lost somehow in my process is the ascent solid stage that waits for cooldown. So we're going to say lock throttle to 0. And we want to lock the steering before we do that. Okay. So ascend solids. Something happened here in the orbit phase. Can I just put a little debug down here? Let's try that. Okay, so we have the diff, base. Well, we have the base up there already. So we have diff, we got aggression, we've got altitude. So that's kind of all we need, really. I want to put the periapsis on here as well. Okay. Okay. So that's all good. Let's try this again. I'm actually going to revert to vehicle assembly because I want to take down the fuel in those solid fuel rockets just to get there faster so we can test this a little more quickly. So let's try that. Okay, command center, camera. I do wish we could get just save this configuration somehow. That's fine. Attitude, let's go like this. And then we'll go 9. Okay. There goes the cooldown. There goes the drop. And we're just falling straight down. Diff equals 62,000. Alt. Ascent angle is 0. Okay. Very strange. So I'm just going to let this play a little bit. Diff equals 62,000. So the ship altitude minus the base. Rams base was 10,000. Because I was below that. That makes sense. This might be part of it. So I talk a few notes and then revert. Okay. Base was 10,000. So right now, the way that this is working is we're actually, I think, going the other way. So ascent 0, diff 62,000. Okay, let's revert that to launch. So the first thing we have to do here is if ship altitude is less than base, okay, I think we're gonna do something like this. Ascent angle equals 85. Or I guess set ascent angle to 85. Else, and we're going to change this to, let's actually just do something like this. Const base ascent okay, apparently I can't do that. Local base angle to 85. This way we can set whatever. If we want to like do a little bit of a more aggressive climb or something, we can do that. Okay. So that's the first thing, is we have to wait to actually get that high before we start turning. So let's save that and try reloading that first. Custom 0. Aha, okay. Let's see if my resetter works. Open the console here. Closed. And then it loads again. Perfect. Alright, let's go to the control center. I'll close KOS. We're going to close this console. Cams. Let's do that vessel view again. Okay, here we go. Wait 7 seconds for cooldown. Flying clear. And entering ascent stage. So you can see now our ascent angle is 85. That's good. We're going to be flying up above 5,000, and then we'll see if it just goes haywire on us again. 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I think we're working. So what should happen is as we approach 72,000, we should slowly drop towards the horizon. We'll see if that actually works in practice. So far, nothing is happening. Oh, there it goes. Shit, because we said 10,000. Okay. So at 10,000, we immediately drop down to ascent angle 5. Okay, that's important diagnostic information right there. So base is 10,000 now, which we're going to drop to make for easier testing. We're going to say, so the ascent angle is reading as 5. Diff is still 62K. Our altitude is 12. Let's revert to launch and try to figure out what's going on with the code. I think it's in here. Okay, so first of all, we have the altitude minus the base. So the base was 10, altitude is 12. So that's 2,000 divided by the difference, which is 62,000. Time for some good old math. 2,000 divided by 62,000 equals 0.03 times 85 equals, well, I actually don't really know what the deal is there. Times base angle. So, ship altitude minus base, 2,000 divided by this, which is 0.03. I'm just going to kind of do all this again. Okay. Our altitude was 12,000. Minus base. So we had 2,000 divided by diff. Diff was 62,000 equals 0.32. 0.032 rather, so 3.2%. Times base angle, which is 85. Equals 2.74 times aggression. Oh. Okay, I think I might be seeing the issue here. The issue is this. Min picks the lower of either of those two functions. So let's actually check the docs again. Basic math. I always get these mixed up in real life as well. Min returns A or B, whichever is lesser. Max returns A or B, whichever is greater. So if we're worried about this going negative, then we're going to return either this whole thing or 0, whichever is higher. So min was always going to be returning 0. Actually, I have no idea why it was showing as 5. That doesn't really make sense to me. However, I think this should fix it. So let's go back to Kerbal Space Program. Let us restart. So we're going to go in here. What's the ScanSat? Once again, some cameras. Let's go vessel view again up there. We're going to say reboot using that action group 10 there, and then we're going to okay, waiting 7 seconds for cooldown. Dropping the boosters, flying clear, and beginning the ascent stage. I should have dropped that to 10K. That's fine. That beautiful view out there. Okay, it seems to be working now. You can see here the ascent angle is now 82. So we're slowly tipping down as we go higher. That's pretty cool. However, our apoapsis is still climbing pretty fast, which means I don't think we're going to be tipping that fast. And that's why we might want to go for a more aggressive approach in the future. That's fine. Apoapsis is still climbing, still falling. You can see that the periapsis is slowly coming up. Okay. Ooh, that's not good. What's the problem here? Line 112. What's the problem? Okay, so something messed up here. So something about my trigger here did not work. Okay, we are falling back to Earth. So I'm going to go ahead and revert this flight, and we're going to do we're going to do some testing right from there. Maybe I can actually test right here. Zoom flight. So let's try turning it off and on again. Fine. I can now type. Say, so let's try each of these. So print body atmosphere exists. Okay. So there's my issue right there. As I was trying to figure out what the atmospheric height is, and that doesn't help me if I am already in orbit. Okay. So that's a good one. Let's try it again though. Can I do it now that I'm back in the atmosphere again? Nope. Okay, so I think that's just my bad. I'm going to revert this before we crash. Aha. This is the problem. So I would have had to say body Kerbin, for instance. What I would like to know is current body. Okay. Ship body. That might work. Because we might have a couple better options here. Actually, that might be enough by itself. So I think I can just say if dynamic pressure is 0. Let's try that. Okay. Let's do some experiments again. I'm just going to use this terminal here to do those for now. Okay. So I'm reading my keyboard inputs at all. Maybe I have to be in here. Okay. Sometimes it just locks you out of there for some reason. I don't really know why. Ah, I'm just a dumbass. That's why. Okay. I would have needed an option to just quit out of this, basically, because it's just sitting here waiting for me to hit that first stage. So, can I temporarily No. Oh. We'll do this the old-fashioned way. Which is to abort. So let's say print ship body name. Kerbin. Okay. Okay. I think I got an idea. So let's do ScanSat 1. Up here, let's say print body atmosphere ship body name height. Let's try that. There we go. That's actually what we want. Okay. So that allows us to get the height of the atmosphere of the current body we're in. So in orbits. Try this. Body atmosphere ship body name. Okay. Okay. I kind of want to show the dynamic pressure in the other areas as well. So I'm going to say here, 14. We don't need that one anymore. And even in the solid ascent phase, I think I'd like to have it. Okay. let's try this again. Gonna start and there we go. Restart the old KOS. Jump into the control center. There you go. The pressure is actually kind of going. There it goes, going down. All right. It was going up because my airspeed was increasing. You can see my nav ball tracking down now. Alright, things are actually going fairly well this time. Burning through our fuel nicely. Okay. We are in orbit stage. Beautiful. Okay. So it's going to wait until we're out of the atmosphere before it basically starts to tilt over, which should be here in a few seconds. Line into horizon for burn preparation. Nice. So my prograde is way over there for reasons I don't fully understand. I'm guessing that has something to do with the orbit mismatch. I have to read about that later. Okay, we're ready for the burn. There we go. ETA to apoapsis, 14, 13, 12. The problem is we're going to run out of fuel here in a second, and then we're going to lose some of our juice. There it goes. However, this might actually work. We'll see. So we are sort of falling back into Kerbin, which is not great. However, our periapsis is coming up. Will come up in time. I think it might. Yes. Barely. Well, that almost worked. We have an apoapsis. Jesus, what happened here? Okay, that definitely did not work. We go to the orbit here. You can see we are way out. Okay. That's enough of that. That's actually interesting. I didn't know you can do that. Okay, that's good to know. Alright, well, it almost worked. Still the same issue, and the issue this time was that the periapsis fell under the atmosphere, so we just still burned forever. But I think that was because we didn't go high enough the first time. So let's try one more thing. I'm going to revert to the revert flight to launch one more time. I'm just going to tweak the actual parameters of the base ship itself this time, including fixing our solid stage, because I actually kind of forgot that that's a big deal with this thing. That's why our main stage is so low on fuel. So revert flight to vehicle assembly. However, that being said, I am going to ascend. I'm going to start that turn a little earlier. I'm going to put a little bit more aggression on it. Let's say 1.2. And we'll up that in there. So we'll up to 75. And just kind of call that good. I'm kind of tempted to just skip this one for now, because I'll be happy if I just get this working. I can manually adjust it from there. So let's call that the goal for today. We're just going to skip that one and call it good. So 75,000, 7,000 starting altitude, 1.2 aggression. So we'll go a little flatter this time, and then give these guys their proper amount of solid fuel. Save. I think that should be good. Launch. Okay. Let's see what we can do here. So, into the command center, turn on our cameras. We will turn on our vessel view to start with, I think. Turn on our attitude indicator. Get into Kerbal, or into KOS rather. Okay, here we go. So you can see our altitude is climbing quite a bit further this time. We're up to 8, 9, 10. So we'll have to, yeah, I think this should work. Waiting 7 seconds for cooldown. Vertical speed drops a little bit. Hopefully this doesn't crash anything. Beautiful. We are in ascent stage. Ascent angle is coming down nicely. Apoapsis is climbing, and our periapsis is also climbing, although much slower. That's fine. We're still flattening out this angle, and we are improving our where's the shore? Orbital velocity right there. Okay, we are in orbit stage. Apoapsis is at 75,000 feet. We're still climbing through the atmosphere. We got down to about 45 degrees there. That's good. I believe I can actually... that's very cool. Beautiful. Oop. Okay, we are aligning for horizon. Aligning to horizon for burn prep. We are circularizing. Should keep circularizing even though we're past the apoapsis because vertical speed is 0 now. Periapsis is coming up. Unlike last time, we have a lot of that stage left. Going to switch to orbit mode here. Okay, periapsis is coming up. Oh yeah. Staged. Shit. Alright, that was so close. However, I am going to have to fix this now. I'd call that good enough for today. So here's what we're going to do is... Alright. We have launched. Almost got there manually. Didn't quite work. Didn't quite calculate our stages and stuff right. Something to kind of tweak in the future, but I think it mostly worked. It was a minor issue, not a major issue, and I will count that a win for today. So let's make our final action here. And we will switch to our interior cam there. And let us open the pod bay doors. Let's rotate the vessel to point at Kerbin. Beautiful. Zoom way out so we have that nice view there. Beautiful. All right, and then let's turn on the ScanSat. What we should see is our current vessel on here somewhere. I still don't really exactly know how to do this. And I think we're active, I'm fairly sure. I believe is this scanner should now be working, which it is. Beautiful. All right, so we now have our little army of ScanSats flying over Kerbin. The orbit script still needs some tweaking, but it definitely worked on that last one. I just didn't quite have the juice to make the final push once we got above the atmosphere. I should also probably add a little thing to. I mean, there's just not really a good way to do that. I think if you. I should add something to test if you switch. So if you get the other node and you are now closer to the periapsis, if that suddenly flips on you, then you should just wait till the apoapsis and circularize from there. However, if we're dropping back into the atmosphere before you achieve orbit, then that's kind of a problem anyway. So that's something we're going to have to figure out a little bit, maybe with some different settings. But yeah, those are problems for another time. Thanks for watching. I'll talk to you guys later.